Today we are going to discuss Edexcel IAL Chemistry Paper 3 October 2019 Part 2. In our Part 1 video we have discussed question 1 and question number 2. Today we are going to discuss question number 3, 4 and 5 of this paper. In question number 3, an experiment is carried out to determine the formula of an oxide of copper. They have given us the diagram as well as the procedure. Give a reason why in step 3 there should be a delay of few seconds before lighting the hydrogen at the end of the test tube. In order to answer this question, first read the procedure. Weigh the empty test tube, place 2 spatula measures of copper oxide in a test tube and reweigh. Basically, in this experiment, we are using copper oxide and we will reduce copper oxide into copper by using hydrogen. So the hydrogen gas is passed into the test tube, and after a delay of few seconds, light the gas at the hole at the end of the test tube. Start heating the copper oxide. After the copper oxide has completely been reduced, turn off the Bunsen burner but continue to pour soaked hydrogen over the product until it has been cooled. Weigh the test tube and copper. Now give a reason why in step 3 there should be a delay of few seconds before lighting the hydrogen at the end of the test tube. Yes, you know that hydrogen reacts with oxygen and it reacts with air and it becomes explosive. So there should be a delay of few seconds to ensure that all the air has been removed. Now complete the table of results. The mass of test tube is 40.27, mass of test tube in copper oxide 43.42, mass of test tube in copper 42.79. Now they are asking about the mass of copper in copper oxide. So how can we find the mass of copper in copper oxide? We can subtract the mass of the test tube from the mass of test tube and copper. So in this way we can find out the mass of copper in copper oxide because the copper comes from copper oxide. So if we will subtract mass of test tube from mass of test tube and copper, 42.79 minus 40.27, then it's 2.52. So the mass of copper in copper oxide is 2.52 grams. Then mass of oxygen in copper oxide. So how can we find the mass of oxygen in copper oxide? We have the mass of test tube and mass of copper oxide, this one, and we have the mass of test tube and mass of copper. So if we subtract the mass of test tube and copper from mass of test tube and copper oxide, then we can get the mass of oxygen and copper oxide because only the difference is of oxygen. So if you will subtract 42.79 from 43.42, we will get 0.63 grams. So this is the mass of oxygen in copper oxide. Now use these results to show the formula of this copper oxide. You must show your working. Okay, so we need to find out the formula of copper oxide. It contains copper and oxygen. So now first we will take the mass of copper and oxygen to find the moles of both. The mass of copper is 2.52. The mass of oxygen is 0.63. We will find the number of moles by dividing the mass by their relative atomic mass value. That's copper 63.5, oxygen 16. Both the values are given in the question as well, so you don't need to check from the product table. Now the number of moles of copper you can find by dividing 2.52 divided by 63.5. So it's equal to 0.039685, and the moles of oxygen is equal to 0.039375. So they are approximately equal. So the ratio is 1:1. So the the ratio of copper and oxygen 1:1, the formula is copper oxide, CuO. Now move on to the next part of this question. The experiment was repeated, however, in step 5, both Bunsen burner and the hydrogen supply were turned off while the apparatus cooled. State how the appearance of solid in the test tube changes as the apparatus cool. Okay, so what will happen? As the apparatus cool down, the copper turns black. So you must write the initial color of the copper as well, red or pink copper turns black, becomes dark because it changes back to its original color. Explain how this change in the procedure affects the calculated formula of the copper oxide. Okay, so what will happen, because this change in the procedure affects the calculated amount of copper oxide. Okay, so because of this, the less mass of oxygen was lost. Why? Because some of the copper has been reoxidized. Which copper reoxidized to copper oxide. So this will be the reason. Now move on to question number 4. An experiment is carried out to determine the molar mass of a solid acid H2X. Describe how 25 centimeter cube of standard solution should be prepared using a pre-weighed sample of 1.13 grams of H2X sample. Okay, they have given you a solid acid H2X and you need to prepare its standard solution, and the total volume must be 250 centimeter cube. So it's a very simple question, but because you are preparing a standard solution, so you need to write all the steps. And if you are the student of Edexcel IAL Chemistry AS level, then in chapter 8 there is a topic where the whole process of making the standard solution is given, so you can also take the points from there. Now, the first step is dissolve the solid acid H2X in a beaker using deionized or distilled water. Why we are using deionized or distilled water? Because it doesn't contain any ion, so it will not affect the purity of our acid and a pure solution will form. Now, after making a solution, you will transfer the solution into the volumetric flask. Add washings and make up to the mark with distilled or deionized water. Keep this in your mind that we are making 250 centimeter cube of the solution. And then you need to mix the solution in the flasks. So because this question is of 4 marks, so you must write 4 points. In the first point, you will dissolve the solid acid in a beaker using deionized water. Then you will use a volumetric flask, add washings and make up to the mark with distilled water, 250 centimeter cube, mix the solution in the flask. Then your standard solution is ready. Now part B, 25 centimeter cube of H2X solution was pipetted through a conical into a conical flask and titrated with 0.213 moles per decimeter cube sodium hydroxide solution. The indicator used was phenolphthalein. State the color change at the end point. Okay, now you have the acid into the conical flask. So you are adding phenolphthalein into the conical flask. So the color of phenolphthalein in acid is colorless. And when you will add alkali from the burette into the conical flask, the color will changes to pink at end point because phenolphthalein is colorless in acid and gives pink color in alkali. Now, in the next part, use appropriate titrations, calculate the mean titer in centimeter cube. Okay, as we have discussed in our previous papers as well, that in order to calculate the mean titer, you need to take the concordant readings. And I hope that you remember that how we can take the concordant readings, the reading which are within zero point 0.2 centimeter cube of each other. So if you will look here, what are the two concordant readings here? Reading numbers 2 and 3, so we will only use these reading. Please keep this in your mind whether it's mentioned in the question or not, but whenever you will calculate the mean titer, you need to take the concordant reading. Here they have not mentioned in the question, but you need to take the concordant reading. So these are the two concordant readings. You will take their average. So the average value is 11.8 centimeter cube. So this is the mean titer. Now you have the volume of sodium hydroxide and you have the concentration of sodium hydroxide. Now in the third part you need to calculate the number of moles of H2X in the 250 centimeter cube of the solution. Now you need to find the number of moles of acid. For that you need to find the concentration and you must have the volume. Okay, then you can find the number of moles of acid. Now look at the start of the question. They have given you the value, the concentration of sodium hydroxide, and you have the volume of acid. You can also check from the start. So there is no concentration of acid given here. So you cannot find the number of moles from acid. So first you will find the number of moles of sodium hydroxide. Then you will look the ratio. Look at the equation. 1 mole of acid react with 2 moles of sodium hydroxide. So the ratio is 1:2. It means 1 mole of acid react with 2 mole of sodium hydroxide. And we have the concentration as well as volume of sodium hydroxide. So first we will find the number of moles of sodium hydroxide, and through that we will calculate the number of moles of acid. Okay. So in the first step we will calculate the number of moles of sodium hydroxide. This question is also very important because this usually comes in exam with different values, but this type of questions are very important, so you must practice these. You have the formula C is equal to concentration is equal to number of moles over volume. You need to find the number of moles. Now you have the concentration of sodium hydroxide that's given in the question. You can check, it's 0.213 moles per decimeter cube, and then you have the volume in centimeter cube. So in order to convert the volume into decimeter cube, you need to divide this with 1000. So the number of moles is 2.5134 10 to power minus 3 moles. These are the moles of sodium hydroxide. And you have from the equation, you know that 2 moles of sodium hydroxide reacts with 1 mole of acid. It means the moles of acid are half of the moles of sodium hydroxide in this question by using the equation given above. So we will divide the moles of sodium hydroxide by 2, then we will find the moles of acid. It's 0.01257 moles. So this is the answer. I hope you have understand this question. Now move on to the next part, part 4 of this question. Calculate the molar mass of H2X using your answer in B2 and the mass of H2X given. Using your answer in B2 and the mass of H2X given, give your answers to an appropriate number of significant figure. Okay, so you need to calculate the molar mass of H2X. Okay, so you have the mass of H2X that was given in the question, 1.13 grams, and you have the moles, 0.01257 moles. So you can easily find the molar mass. Point 0.01257. So you have the answer 89.918, approximately 90. So this is the molar mass of H2X. Now move on to the part C. The maximum uncertainty each time in a burette is 0.05 centimeter cube. Okay, here the key point you need to remember is that when we take the burette reading, because we take the initial as well as final reading, so always multiply the uncertainty value with 2. Okay, this is very important when you are taking the initial and final reading of the burette. This is a common mistake usually done by the student. So when you are calculating the percentage uncertainty, so you have the percentage uncertainty 0.05 and you have the volume, the burette reading 11.7. But because you are taking the percentage uncertainty of burette reading and you take the burette reading 2 times initial and final reading, so you will multiply this with 2. And as it is percentage uncertainty, so we will multiply this with 100. So the value of percentage uncertainty is basically 0.9%. And because it's percentage uncertainty, so we can write plus minus 0.9%. Okay, now move on to the next part. The percentage uncertainties in the 3 titrations are similar. Suggest how the percentage uncertainty in a burette measurement could be reduced without changing the apparatus. Okay, how we can reduce the percentage uncertainty of the burette reading, and we have discussed, and you know that if we increase the reading, if we will take the larger readings, the percentage uncertainty error reduced. So what we will do in order to increase our value of reading, use a more dilute solution of sodium hydroxide. So it will increase your titration reading and it will reduce the percentage error. Okay, this is question number 4C part 2, and this is all for question 4. Now move on to question number 5. Limonene and oil can be extracted from oranges in 4 steps. In step 1, grated orange peel is added to some distilled water. The mixture is heated under reflex for about 10 minutes. Draw a labeled diagram of the apparatus used to reflex the mixture. So you need to draw a label diagram of the apparatus. So you will draw a round bottom or pear shaped flask containing mixture. You must show the heat. So you must draw the, I'm not very good in drawing. So I'm doing a rough drawing here. And you must show the heating or heat source and the mixture of orange peel and water. You need to show the whole apparatus of the which is used for heating under reflex. So you need to draw the proper apparatus for this. I'm just keep this in mind that I'm just drawing a rough diagram and you need to label it as well. It's water out, water in. So you must draw a complete labeled correct diagram. Now move on to part B of this question. In step 2, the mixture of step 1 is distilled. The distillate contains a mixture of limonene and water. Complete the diagram of the separating funnel by drawing the aqueous pentane layer and labeling them. So you need to draw the aqueous layer as well as the, because obviously both will be separate. So you need to show the aqueous layer and the layer of the pentane. That is basically your organic layer. Describe how the separating funnel is used to obtain the pentane layer. Okay, so what you will do, first you will shake and invert to release the pressure. Then you will allow the separating funnel to settle down, run off the lower aqueous layer, and then run off the pentane layer. So first you will shake, invert, and release its pressure. And allow to settle and run off the lower aqueous layer first. Then the aqueous layer will run off. Then the second layer, the organic layer, will be run off. Okay, in a separate container. So in this way you can separate both the layers. Now In part C, 150 milligram of limonene is produced from 23 gram of orange peel. Calculate the percentage of limonene by mass extracted from the orange peel. Okay, so basically we need to calculate the percentage of limonene in orange peel. So it's equal to, the total amount of orange peel is 23 grams. And we have limonene 150 milligrams. So first we will convert 150 milligrams into grams. So we will divide 150 by 1000 or multiplying it with 10 to the power minus 3. So it will be converted into grams. And as we are finding the percentage, so we will multiply this with 100. So the answer will be 0.65217%. Now 0.01 mole of limonene decolorized 0.32 grams of bromine. Explain what these results tell you about the structure of limonene. Okay, it is decolorizing bromine water. So it shows that there is a presence of double bond in this because this is decolorizing bromine water. And 0.001 mole of limonene decolorized 0.32 grams of bromine water. So first you need to find the moles of bromine. You have the mass of bromine and you have the MR of bromine. That's given here 160. So the number of moles 0.002 moles. These are the number of moles of bromine. Now the ratio of moles of limonene to bromine. If you look, the moles of limonene 0.001 and moles of bromine 0.002. So you can see here the ratio is 1:2. Okay, so it shows that there is two alkene carbon-carbon double bond per molecule of linolone. So this is all about this paper. Now let's subscribe on my channel so that I will upload more videos. If you have any question, you can write in the chat box or the description box. I will answer that. So thank you for today.